Hi everyone, here is my Module 2 Erosion Bottles presentation. So the first step of the design process, ask. My question was, what happens to unprotected soil when it rains, and how do plants help soil survive? So the imagine step, test the issue of what happens to unprotected soil when it rains, and test how exactly plants help soil survive. And then I was going to use the erosion bottles to test these questions. For this step in my ask step, I really started to dive into the simulation module that was provided to us for this project. And I kind of looked around at the different soils and tried to make a prediction as to what I think was going to do best, just the soil alone, the soil with some mulch in it, or the soil with grass in it. So in my plan, I decided to use 3 bottles to test those questions. One with just soil in it, one with soil and mulch, and one with soil and grass. So my prediction was that the one with just soil was going to create the most dirty water because there wasn't anything protecting the soil. The one with the soil and the mulch was going to do a little better, but not too much better because, again, there wasn't really much protecting it. And then the last bottle, the one with the soil and the grass, my prediction was going to be that it was going to be the best because it had the roots and it had the plant protecting the soil. And after looking at those simulations and those module simulations, it helped me to come to this conclusion as well. So here is my create part of the design process. So I had my 3 bottles that I talked about. The one over here in the clear bottle was just the soil. I had one with soil and some mulch in it, and then my last bottle was with soil, and unfortunately I tried to grow grass, but it just didn't end up working out. The seeds didn't grow at all in the bottle, so I ended up having to just dig up a patch of grass with the roots included and put into that last bottle. So here are some videos. I'm going to go ahead and play it. I set up my bottles on a little fire column that we have outside, and I put a little shovel underneath to kind of give them an incline that it would need to get that water to run off into the cup. So here's the first bottle with just soil. I'm going to kind of try to fast forward here so you can kind of see the main part of the video where it's beginning to drip into the cup and coming out of the bottle. So there you can see that water is very dirty. Okay, and then I'm going to move to the next slide. So here is my second bottle with the soil and the mulch in it. So here, as you can see, it's coming out. It's a little clearer than the first one, but not much better. It's still very dark and dirty. And then here is the last bottle with the soil and the grass. And again, I'm going to kind of fast forward this a little bit so you can see the water starting to come out. Okay, there it is. And as you can see, it's much, much clearer than the previous 2. So then here are my pictures of what it ended up looking like at the end. So here's the first one. It's very, very dirty. The second bottle with the soil and the mulch is a little clearer, but as you can tell, not much clearer. And then here's my last cup, of just the soil and the grass. So as you can see, it's much clearer, but still I think it's a little dirty. I definitely would not want to drink any of this water. So here are my improved part of my design. So to improve this project, I could add more things to the soil and mulch bottle, things like leaves and sticks, so that the runoff water could be a little clearer. I thought that the runoff water from this bottle was almost the same color as just soil bottle. And I could also spend more time growing grass in another bottle and compare this bottle to the dug up grass bottle. I still think the bottle with actually growing grass in it would make it the clearest. So here is my STEM practices chart. So for the science, I highlighted ask questions, develop and use models, plan and carry out investigations, and obtain, evaluate, and communicate information. So I thought this project did all 4 of those things because we had to start off with a question, we had to develop and use those models of like what it would be like in the real life, we had to plan out and carry out the investigation, and then we had to obtain, evaluate, and communicate information that we learned from doing this activity. And then for engineering, develop and use models, plan and carry out investigations, and obtain and evaluate and communicate information. So pretty much the same from science to the engineering side. And then technology, recognize the role that technology plays in the advancement of science and engineering. I highlighted that because of using that simulation at the beginning of the design process and trying to make prediction. And then for the math side, make sense of problems and persevere in solving them. And then lastly, the NGSS standard was this one: ask questions, make observations, and gather information about a situation people want to change to define a simple problem that can be solved through the development of a new or improved object or tool. Thank you so much for watching.